The largest single object we have ever found in the universe is not a galaxy. It's not a cluster of 1,000 galaxies either. It's one thing, one point. And it outweighs entire galaxies. We call it Phoenix A. One of the most massive black holes ever measured. Right now, almost 6 billion light-years away, there is a place where the universe folds so hard that light itself can't climb back out. And here's the strange part. If you could stand at its edge and send a beam of light racing along its horizon, that beam would take more than 2 months just to loop around once. 2 months for light. We keep calling it the largest thing in the universe, but when you finally arrive, there is almost nothing there at all. You're not looking at an object. You're looking at the place where an object fell out of existence and never stopped falling. Phoenix A is a black hole, one of the most massive we have ever measured. And by some estimates, the most massive of all. But size isn't really the story here, because the closer astronomers look, the less it feels like the biggest object in the sky, and the more it feels like a wall, a limit, the edge of what the universe is even allowed to build. By the end of this, you'll understand why this might be the largest black hole that can ever exist, and why that quiet little sentence unsettles astronomers more than its size ever could. So let's go and stand next to it. Start with the number, because you need it to feel everything after. Our sun is heavy. 1 million Earths would fit inside it. The black hole at the center of our own galaxy, Sagittarius A star, is about 4 million suns. That already sounds impossible. Phoenix A is estimated at up to 100 billion suns. Not million, billion. Roughly 24,000 of our galaxy's central black hole poured into one. Now, that up to matters. The exact figure is genuinely hard to pin down, and a few other giants sit in the same weight class. But even at the cautious end, we're talking about something heavier than entire galaxies. Its edge, the point of no return, is around 4,000 times the distance from the Earth to the Sun, about 100 times the width of our entire solar system, out past Pluto. One object, heavier than some entire galaxies. And it is still eating. But the size isn't the frightening part. Here's the catch. A thing this big does not sit quietly. As gas falls toward Phoenix A, it doesn't drop straight in. It spirals. It piles up. It grinds against itself until it glows, a flat, burning disk wrapped around the dark. At times, we think it fed so violently that it lit up as a quasar, a single object outshining 1,000 galaxies around it. But glowing isn't the real trick. The black hole also fires back. 2 narrow jets of particles, launched at almost the speed of light, drill straight out through the surrounding gas and carve a pair of bubbles into the cluster, each one larger than a galaxy. That is the tool. That is how a single point reaches across millions of light years and rearranges 1,000 galaxies. Long before astronomers knew how massive Phoenix A really was, they already knew something extraordinary was hiding there. Not because they could see it, but because they could hear it. Those enormous jets are what made Phoenix A one of the brightest radio sources in the sky. The X-ray telescope Chandra can still see the scars. And here's the part that still sounds like science fiction. Those jets may not be powered by falling matter alone. They may be drawing energy directly from the black hole's spin itself. The rotation of a hole in space-time turned into a beam. We're not certain, it's still argued, but it's real physics, not a metaphor. And remember, radio astronomers heard those jets long before anyone weighed the giant at the center. We knew it as a voice before we knew it as a monster. Still nothing your eyes could ever catch. And it just reshaped 1,000 galaxies. And it's still not the strangest part. Now here's something almost tender in the middle of all that violence. The galaxy around this monster is not dying. It's being born. The Phoenix cluster has the highest rate of new star formation ever recorded in the heart of a cluster. Roughly 700 times faster than our galaxy makes stars. Sit with that. The single most destructive object we know of sits inside a galaxy we named after the bird that burns and comes back. Fire and rebirth in the same place at the same time. Nobody planned the name to fit this well. It just does. So let's ask the obvious question, the one astronomers have been quietly dreading. How do you build this? Black holes grow by eating. But eating is slow, and there are rules. Feed too fast, and the light and heat you throw off pushes your own food away. A black hole can basically starve itself. Given those rules and the age of the universe, reaching 100 billion suns should be almost impossible. There simply hasn't been enough time. And yet, here it is. The James Webb Space Telescope keeps finding black holes that are already far too heavy, far too early, all across the young universe. The math keeps not working. So some scientists have started to wonder something uncomfortable. What if the biggest black holes didn't start as stars at all? What if a few were seeded at the very beginning, born enormous, before the first galaxies, before the first light? We don't know. That's the honest answer. Here's what we can see. You decide. And now the part that changed how I look at this thing entirely. For years, the question was simple. How big can a black hole get? Is there a limit at all? Recently, a team led by the astrophysicist Priyamvada Natarajan tried to work out the ceiling, the maximum, the largest a black hole is physically allowed to become before it chokes off its own supply for good. The number they landed on was around 100 billion suns, which is almost exactly where Phoenix A already sits. Sit with that for a second. This might not just be the largest black hole we have ever found. It might be pressed right up against the largest black hole the universe can ever make. Not the biggest one so far, the biggest one possible. We may be looking at the ceiling of reality, and something is already touching it. Let's stop here for a moment, because Phoenix A isn't overwhelming in one way. It's overwhelming in every way at once. It outweighs galaxies. It fired jets clean across a cluster. It blazed as a quasar, and it sits at the very edge of the possible. And all of that, every bit of it, is happening around a center that, when you finally reach it, holds no surface, no rock, nothing to touch. The largest object in the universe is, at its very heart, not an object at all. So here's the question worth asking. Why do we keep pointing our best telescopes at something that could swallow our entire solar system without noticing? Because a limit is a gift. For most of our history, the universe just felt endless. Bigger numbers, bigger objects, on and on, with no floor and no ceiling. And then we find this. A place where the universe seems to say, quietly, this far and no further. The most terrifying object we've ever found might also be the clearest edge we've ever been shown. Fear turns into something else the moment you realize it's holding a door. Almost 6 billion years ago, before our sun existed, before the Earth had cooled, the light leaving Phoenix A right now began its journey toward us. It crossed a distance our minds can't really hold, and tonight, a sliver of it lands on a telescope built by a species that measures its whole life in decades. We are small in a way that's almost funny. A few soft creatures on a wet rock, looking up, naming the heaviest, hungriest thing in the sky after a bird that rises from its own ashes. And maybe that's the truest part of it. Because the largest thing in the universe isn't just a monster. It's a boundary. A place where creation and collapse press against each other so hard that not even light can tell you what's on the other side. We found the edge, and we're still looking anyway. There is more to explore beyond the stars.